Hi everybody! This video is another contribution to the series of simple shaders whose code takes only a few lines, yet the resulting effect can enhance the appearance of your game. The effect I present today smoothly transitions from a pixelated screen to a sharp one, or vice versa. So, what is a pixelation? In the realm of computer graphics, pixelation occurs when a bitmap or a portion of it is presented at a size so significant that the individual pixels become visible. This results in the image being described as pixelated. There are many online tools where you can drag and drop an image to instantly receive its pixelated version. However, we want to apply this effect dynamically, ideally to the entire viewport of our 3D game. As usual, we will use a screen reading shader. By the way, please ignore this red star. I was experimenting with a dynamically generated star field using a different shader, and I didn't want to remove the unfinished version from the project. I'll be covering this effect in some of the upcoming videos, of course, once there are more stars of more types. So, let's create another canvas layer with a color rect as its child node. In fact, I already did that, so the canvas layer is here as canvas layer 2, and its child node I renamed to pixelation and change its layout so it's contained in the full rectangle. Let's add a new material, shader material of course. Click the material and to the shader we will create a new shader here. New shader, and let's call it pixelated for instance, and we'll put it to the shaders folder. Open canvas item, this is correct. Create. Double click the shader, and of course I forgot to no, it's okay. Double click the shader. First, let's set the render mode to unshaded, because we only want to modify the existing image in the viewport and there is no need to work with lighting. Render mode unshaded. As we know from previous tutorials, Godot 4 uses the following methods to read the contents of the viewport. We will have the variable name in uppercase for compatibility with previous versions of Godot, where we can omit this declaration. So uniform sampler 2D and screen texture, hint screen texture, repeat disable and filter nearest for pixel perfect. Okay, this time we will have only one more uniform parameter through which we define the pixel size of the resulting effect. The default value of 1 means that nothing will change on the screen as long as it's 1. Although an integer could be used, I've made this parameter a float to make it easier to control from GDScript. So it would be uniform float pixel size, and we will use a hint range from 1 to, let's say, 16, and the step would be 1 and default value 1. Good. For the actual calculation in the fragment function, we will take the coordinates of the current pixel and subtract from them the remainder when divided by a number corresponding to the size of the target pixel, the larger one. This ensures that all fragments in a square with a side length of pixel size have the same color. So we will do it here in the fragment function. Let's define the x-coordinate. That would be frag coord x, the x-coordinate of the particular pixel on the screen, and we will subtract the remainder, the modulo, of the same frag coord x divided by the pixel size. Okay, and let's copy and paste and do the same for the y-coordinate. Would be y here and y here. Nice. In addition, we can add centering of the new pixel of the center of the original one. This step is optional and depends on the desired final effect you want to achieve. Let me just use it here, so I'll make float, let's call it, sorry, shift, and it would be the rounded value of the pixel size divided by 2. Okay, and finally we obtain the color of the original pixel from the back buffer of our viewport so that we can assign it to the new internal variable, not new of course, to the internal variable color after all transformations. So color would be texture from our texture, the pixel, screen, no, screen texture of course, and the coordinates are vector 2, x plus shift, and y plus shift, and of course because we can have different resolutions, we need to multiply that with the screen pixel size. Okay, and nothing is showing because our canvas layer is not visible. Let's click it here and click the pixelation again and shader parameter here. Let's change it to some higher value. Yeah, it's being pixelated. Can you see it? Great, it's working. So that covers the shader part. You can experiment with the pixel size parameter, of course, and observe the results. We just did that, but we'd prefer the game code to handle it. Let's move on to GDScript and finish the effect. I'd like to remind you that in all the videos we are working with a project for which I've uploaded a complete tutorial, and you can clone its source code from GitHub. The link should be provided in the description of this video. So let's switch to the script editor, and we will drag the color rect called pixelation to the script while holding the Control key, so we get this whole declaration instantly. Now it's necessary to add a new variable to keep the current pixel size value. We'll declare it here, var pixel size starts at, let's say, 16 to make it really pixelated. Let's add a new function, pixelate, that would control the shader parameter change over time. We will do it here, for example, just below the process, because we'll call it from process afterwards. Func pixelate, and the parameter will be delta, because we want to use this value of the frame time to change the pixel size smoothly, regardless the frames per second performance. And we had the pixelation node. We will get its material and set shader parameter, which is called pixel size, and the value is pixel size. Okay, and now the transformation. So in every frame we will change the pixel size, we will subtract delta, but delta is too small. Usually it would take 16 seconds to get to 1 or 15, so let's multiply that by 4, for example. And finally We want to stop it when the pixel size reaches 1. So let's add the condition if pixel size is less or equal, just to make sure that if we just get below 1, it would stop anyway. Pixel size is 1. Good. That's enough for the transformation, and finally we will call this function from the process, and only if the effect is still in progress, so the pixel size is greater than 1. Let's put it here. So it would be if pixel size is greater than 1, let's call pixelate with the parameter delta. Okay, that should be everything. Let's start the game and observe the effect after I click the start button. I think it's working. Getting to 1 and the game is sharp. Cool. If the transition was too fast or too slow, you can change the multiplier in the pixelate function. Here it is, this number 4. Or you can omit the function altogether and use a tween or animation player to define more complex pixelation behavior. The important thing is that the shader works and can be used anywhere in our game. Good job! Thank you for watching. This time it was a bit shorter, but maybe that's a good thing because not everyone has time to watch complex tutorials that last for hours. And even a simple effect like this one can add to your programming repertoire. I try to add new videos at least once a week, so if you enjoyed it, please click on subscribe and you won't miss anything new. Take care, and I look forward to the next video.